Hello everyone, welcome to another episode of Anju Speaks Tech. Now this new year we will start the discussion with a topic in partitioning versus sharding in YugabyteDB. What is partitioning? Partitioning is the process of splitting a large table into smaller tables for managing data efficiently. So whenever you are trying to apply a data lifecycle management on any table, and after say certain period of time you want to purge the data. So then partitioning is the sort of the method. So in partitioning, the large table is split into smaller multiple physical tables that are logically considered as a single table. Now sharding is a mechanism to break large tables, even partition tables, into smaller chunks spread across multiple database nodes based on some strategy. In YugabyteDB, a table can be sharded based on hash or range of the primary keys. Now, default sharding mechanism in YugabyteDB is hash sharding, but we can use range sharding as well as per your business requirement. Now, in YugabyteDB, each table, be it any normal table or whatever we are discussing here, in case of partitioning, parent table or child table, is further split into shards, and the shards are called tablets. So partitioning has a concept of parent table and more than one child tables, and these tables are also split into multiple tablets automatically in YugabyteDB. So in a nutshell, ultimately all tables are sharded and distributed across database nodes in YugabyteDB. Now here I have tried to showcase one such example. So consider this as a replication factor 3 cluster, which means that the cluster retains 3 copies of data of one table. Okay, so and by default, YugabyteDB splits one table into one tablet, that is one shard per node, but this can also be customized. Now, in this example, we have one parent table called product details, and I have shown here 3 child tables, that is one for Jan 2025, and Feb 25, and March 25. So, likewise, you can have as many as you want as per your partitioning strategy, be it monthly, weekly, or daily, whatever. So what is interesting to note is that every table, say if I consider this Jan 2025 table, which is a child table, so that table will further be split into 3 tablets. Okay, so and one tablet will reside on node 1, another on node 2, another on node 3. So here you can see that the tablet 1 leader resides on node 1, tablet 2 leader resides on node 2, and tablet 3 leader resides on node 3. Now, as I mentioned, that this is a replication factor 3, that means that it will have 3 copies of your data. So that's why you can find 2 tablet 1 followers on the remaining 2 nodes. So if I consider tablet 1, so tablet 1's leader resides on node 1, and tablet 1 followers are residing on node 2 and node 3. In a similar fashion, you can see that for tablet 2, leader is residing on node 2, and the other 2 copies, they are followers, so they are also available on node 1 and node 3. And for tablet 3, we have a leader on node 3, and the followers for the tablet 3 leader are also available on node 1 and node 2. So this is not only for the child table, even for the product data, that is the parent table, that will also split into uh, one tablet per node or one chart per node. Okay. So next we will have a demo on this, and we will show you. I shall show you that how uh, this is done, or how it is happening in YugabyteDB. So I'm switching back to my Git pod where I have opened a YugabyteDB project, and I have already created a sample database named partition sharding demo. So here, first I shall create one table called product details. Okay, So I have created a table. Let me check the description. So now you can see that I have created one table where it is partitioned by range, and the partitioning column is on batch date. Okay, so it is being partitioned by batch date. So next what I will do is I shall create, as I shown in on the slide, that I shall create child table. So first I shall create one child table, and then I will go to the web UI to showcase that how it has automatically been split into multiple shards. Okay, so let's create the first child table. So here I think just I need to change rewrite the state range once. So I'm going to create 2025 01 to 2025 01 sorry not 01, that is 0201. Why is this so? It's just because the upper range is exclusive. So if I consider till 31st of Jan, so it will only include 30th of Jan. So that's why I have to put 1st of February, so that the whole January month can be included. Fine. So let's see. Yes, so one table has been created. Now again, let me check the description of product details. Okay, so now you can see that here a new information is available. It says that one partition is available. So let me do a plus, which will show me additional information. And here we can see that yes, we have a child table available for this product details table. So now let me go back to the UI. Let me refresh it. Yes, so now I have created, this is the database partition sharding demo, and here you can see that two tables. One is that parent table, that is product details, and the child table that I have just created. Now, if I go to any of these tables, I can find that automatically these tables has been split into three shards, that is three tablets. And you can see that the leaders are available on one leader is available on each node. So one is on the one is on two, and one is on three, and the follower nodes are also available on the remaining nodes. In a similar fashion, if I click on this product details Jan 2025 for this table also, I can find that it has split into one tablet per node, and the leaders are available on these nodes. That for this tablet starting with 6p, the leader node is the leader resides on node 3, and then we have the remaining two follower tablets available on node 2 and node 1. So that's how it keeps three copies of data, and anyway, all the tables are automatically uh, split into multiple shards. So in YugabyteDB, what we can say is that if, when you are partitioning, so partitioning is obviously you are splitting up a large table maybe into a smaller tables, but each of the smaller tables are automatically further divided into smaller chunks, and they are distributed across the nodes. Now, before we wind up, let's validate the following statement. So in one of my previous slides, I have mentioned that in partitioning, the large table is split into smaller multiple physical tables that are logically considered as a single table. Now, what does it mean? That when if I just execute a select statement on the product details table, it fetches data from all relevant child tables. So, and one point to note is parent table, there is product details table for our case. So the parent table doesn't hold any data. It just acts as a virtual table. So we will validate all those things. Now to do that, what I will do is I shall create two additional child tables first, and then I shall insert three records. One dated Jan, another dated Feb, and the last one dated March into product details tables, and I shall execute a select and let's see what happens. Okay, so here I have this query. So this is for Jan. Now I will just modify this query and create the additional two child tables. So now I'm creating a child table for March. Created, sorry, for Feb. Now I'm going to create for March. Okay, so now I shall create for March. It's from 1/3 to 1/4, and I have to change the name as well. So it should be now this is Feb, but I will modify it to March. Okay, so now I have created two more additional child tables, and let's look at the description of product details tables once again. Now you can see that instead of one, now we have three child tables, one for Jan, one for Feb, and one for March. Okay, so now let us insert three records to product details tables. Insert into product details values, product ID say 100, then batch name say batch A, and then we have to provide batch description. So this is BES1. Then I have batch date, that is 2025. Then 01, any date of Jan will work. Okay, so the first record has been inserted. Next, I will just change these values a bit. So I will make this 200. The batch, let's say, make it B. Description, let's make it 2. And now I shall supply a date of February. Okay, so let's say it is 20th February. So second record has also been inserted. Now it's time to insert the third record. So okay, this is 300. Let's make it 300. Okay, product details values. Oh, sorry. Values 300. Then we will have batch C. Then description say 3, and I shall provide a date of March. So three records have been inserted. Now let me do a select on product details. So product details fetches all three records. Now, what is interesting to note is product details, that is the parent table, it doesn't store any data. So all data resides in the relevant child tables. How can we validate that? Yes, we can. So let's write the select query part with a slight modification. So I'm adding a phrase as only. So what it will do is it will only query the product details table, that is the parent table, and it will try to fetch data. And you can see that the product details table doesn't hold any data. Now what I will do is one by one I shall query the parent tables with that only phrase. And if I do that, I can find that okay, one record was inserted into the Jan partition, another one was inserted into Feb partition, and the third one was inserted into the March partition. Okay, but when we just select or insert into product details tables automatically. So for insertion, when we just do an insertion to product details tables, it will automatically go to the relevant child tables. So if there is no such relevant child table available, it will go to the default one. But here we haven't created a default. But in actual scenario, we should also have a default partition where when it will not fit for any other child tables, it will go to that default partition. But on the other hand, when we'll do a select, so it will basically select uh, select start from. Now we are not using that only phrase. So if we just do like this, a normal select without that only phrase, so it will fetch all the data from all child tables. So that's all for this episode. Um, until we meet again, stay well, keep learning, and if you like the content of this channel, so please like. Also, you please comment how you are thinking. Please provide feedback to make it better, and also you can share the topics that you want to learn or want to hear from me. Thank you. See you in the next episode.